There we go. This should also actually be our last day of notes for this chapter. Gonna finish it out today. I'll talk about it at the end. What's up? We'll talk about it at the end. Okay. Soon. Soon. Teaser, teaser. I'll take away my joy for changing things. Just come on. All right, so we're going to want to have this cosine formula up here. I do have it on our next page, so it's up here on the top right. So if you didn't quite get it written down, I have it up here. So we're going to find the angle between vectors u and v to the nearest tenth of a degree. So we're telling you where to round. So what we need to have is I need to have my dot product of the two vectors. I need the magnitude of one vector and the magnitude of the other. So we need the dot product of u and v, the magnitude of u, and the magnitude of v. So that's where I'm going to start, is I'm going to find each of those individual pieces. So let's find the dot product of u and v. And that's what we did yesterday when we really started looking at dot products. There we go. Where we take the x pieces, so my -5 and my 4, and multiply them together. And then we're going to add that to the product of the y pieces, -2 and the other 4. Yes. I'm going to simplify it in a couple of steps, but yes, that's where we're headed. So -5 times 4 gives me -20 minus 8, which gives us -28 as our dot product. So then I'm going to find the magnitude of vector u. So the way we find our magnitude, that's our square root of the x and the y that make up that vector. So we're going to have our -5 squared plus -2 squared. So we're going to have the square root of 25 plus 4. So we're going to have it as the square root of 29. Same thing for the magnitude of v. Same process. Our magnitude of vector v is the square root of 4 squared plus 4 squared. 16 plus 16. Square root of 32. And you can simplify that right now if you want to. We could pull that out and make it 4 square root of 2. Totally fine. We're going to be doing other operations with it, so I'm going to leave it unsimplified for right now, because we know since we're going to be using a cosine thing, we're probably typing the sucker in the calculator, and I'm just going to leave them unsimplified because that makes my life easier. Questions on how we found any of these pieces, because we just kind of flew through all those. Okay, cool. Just checking. So then what we're going to do is we want to find theta. And we know that cosine of theta is going to equal my dot product on the top. So my -28 is on the top. And we're going to multiply together our two magnitudes. So we're going to have our square root of 29 times my square root of 32. which we can simplify this a little bit just to make our lives easier when we type things in. A negative 28 over the square root, and we can do 29 times 32, because if they're under the square root, we can multiply them together. Which I love that I didn't actually write it down. 29 times 32 is 928. So what can we do to get theta? Inverse cosine, arc cosine. So, oh, I don't think I have the calculator open. Oh, I love that. There we go. So I'm going to open my calculator. Boop. So we're going to do our inverse cosine of the fraction, and you can type it in as a fraction. We've got our negative 28 over the square root of 928. And you can just type it in like this. Oh, I love that. There we go. Boop. And it's going to give us 156. We did say to the nearest tenth, so 0.8. So theta equals 156.8 degrees. So between these two vectors is an angle of 156 degrees. Questions? Okay, we're gonna try it again. I'm never just gonna do it once. So same thing. We're gonna find the angle between vectors u and v, and I've given you a new u and the new v. The new u is 3, 1, and the new v is 3, negative 3. So very same thing. I'm going to find my dot product. I'm going to find both my magnitudes, and I'm going to smash everybody together. So I'm going to start with u dot v. I'm going to start with my dot product. And that's when we take our x's, 3 times 3, and we add it to the product of the y's, 1, negative 3. So that's going to give us 9 minus 3, which is 6. Then we need our magnitudes of each of these. So I'm going to get my magnitude of u, which is the square root of 3 squared plus 1 squared, or square root of 10. The 3 squared easier. Say it again? Oh, behind certificate. There should be some back there. If there's not, let me know, because I have a box of them. Oh, behind the shower curtain. Go left her. Leslie. Left her. Behind the shower curtain. Yeah, back there. So then we need to find our magnitude of v. Same vibe. We're going to take and do 3 squared plus negative 3 squared. So 3 squared is 9 plus negative 3 squared is 9, so square root of 18. So then to find the angle, we have our cosine of that angle is equal to the dot product on the top, so our 6, and then the product of our two magnitudes. So square root of 10 times square root of 18. Which we can simplify that to make this cosine of theta equals 6 over square root of 10 times 18 is 180. And again, you could simplify that if you want to, but since we're typing it in the calculator anyway, might as well just let the calculator do the work for us. I mean, if you want to simplify it, you can. Definitely know this perfect square in 180. We could simplify that. What do we get for our theta? 63.4 degrees. Questions, okay? We're going to do 2 more like this, so we can practice this a couple more times. Boop. All right. Same thing. Exact same thing. We're just doing it 2 more times so we can practice it, because the next piece is moving on in like a different direction. So I want to make sure we get time to practice this, okay? So same thing, we're going to do our dot product and we're going to find all our magnitudes. So we're going to do u dot v which is going to be 9 times negative 6 and 5 times 7. Sorry, I should be before I start just like plowing through stuff. Mm-hmm.
We did the inverse, right? Or no?
Yes, we did inverse cosine to get the decimal.
Now I'm getting something wrong.
Alright, are you in radians?
No, I just forgot
Cool, cool. All right. So what do we get for our dot product of u and v? Negative 19. So then go to our magnitude of u. What do we get for our magnitude of u? Square root of 106. Go to our magnitude of v. It's good practice for you guys. Square root of 85.
I got 78. Oh, wait, no. 36 and 42.
49.
49.
You did the product of 6 and 7 instead of the square, so. It's so easy to do that, especially when they're right against each other. All right, so let's get our angle. Cosine of theta is our negative 19 over the product of our magnitudes. So 106 times 85, which you can simplify to be 90/10. What is our angle? 101.5 degrees. Feel like we're getting to be pros at this. Joanna, you look confused. Are you good? Okay. All right. One more, because they like to toss it at us in these weird ways. Last one like this before we change directions and look at the last bit. So we've given it to you in terms of our unit vectors. All that means is write it yourself as a vector in its component form. So with u being 2I plus 4j, we can rewrite that to be that vector u is 2, 4. And with vector v being negative 12I plus 6, what's that one? Negative 12, 6. So again, when it's in its linear product form, it's not super complicated to get it into the composite form. We just have to remember that. He's working diligently. What is our dot product of u and v? 0. Which means, do I need to do anything else to know the angle between them? No, because what does that mean? It's not going to be 0. What does a dot product of 0 mean? They are perpendicular, which means what's the angle? 90. So this means they are, our new word for that was orthogonal, which means perpendicular. Which means it's 90 degrees bang on. So when your dot product's 0, it means it's 90 degrees, which you can still do the rest of it if you want to. You can find your magnitude, set it up, inverse cosine of 0, that's going to give you that 90. Okay. So questions about finding the angle between. We have one last piece to put in with our dot products. Naturally, we have to do some stored problems. Yes, dear. Because it means perpendicular when the dot product is 0. Or you can keep going, do your magnitudes. And when we have our, set up our cosine theta of 0 over whatever hot mess this is, it's just going to be inverse cosine of 0. Inverse cosine of 0 is 90 degrees. So we have to add in a few story problems that use dot products. So we're going to use force, not Star Wars force, physics force. As fun as it would be to. So we're going to have that force is applied to an object. And it's got a displacement. So force is going to be given to us as a vector. Displacement is given to us as a vector. So we're going to be able to find things using our vector operations. And the units are going to be weird. Units are things like foot-pounds or meter seconds. Like, they're weird. They're just weird. So whatever units that you're given are, just put both of them there and go, okay, crazy unit, that's what you are. Okay? So I was nice, and I printed you guys out the story problems so we didn't have to, like, speed write paragraphs for the next 20 minutes. And yes, I know our copier is in a mood, so some of the words are a little unclear, but they're all there. I wrote them out so we didn't have to. We didn't have to speed right there. These are our 2 story problems we're doing. We're doing 2. Okay, so what we're gonna have here is we've got that our work. So what this W means is the work. And work has really weird units, so this is work. What's up? Oh, love that. That's called, I cut them in piles. And I don't cut through them to make sure they're properly cut. Yeah, if you ever wind up with things like that, I always make a pilot because I cut them in like units of 10. Because I'm lazy. So we've got our work is gonna be our force using the dot product with our displacement. And yes, it's story problems, but hey, there's no bearings in it. We love that. No cardinal directions either. Not a north, south, east, or west to be had in this one. No boats. Just children making silly choices. Okay. So units are going to be weird. I think in both of ours problems they become foot-pounds, but that's okay. Bless you. Okay, so we're going to start with the Mason problem. So Mason with a vacuum cleaner. So I still see at least a couple of pencils writing, so I'm going to give you guys a few more seconds on this page. Since we are American, foot-pounds is going to be our most common unit that we have here. But I'm giving you just a few more minutes, a couple more seconds, because I still see several people writing. Okay. So we're going to start with Mason. Here, pushing a vacuum cleaner with a force of 90 pounds. The handle makes a 63-degree angle with the floor, and we want to know how much work he does to push the vacuum cleaner 8 feet. Because this is what we think when we clean anything not good. So, like most story problems, I'm going to start with my beautiful art skills. Holy cow, he's got tiny legs. That's okay. So here's Mason. He's pushing his beautiful vacuum cleaner. I am a fine artiste. I mean, it looks more like if you put a little bag on it. There we go. Old-timey vacuum cleaner with a little bag on it. So his vacuum cleaner is at an angle of 63 degrees. And we want to know how much work to push it 8 feet. So what we have is information about the force with the angle. And then we're going to be pushing it 8 feet. So we're going to have two different vectors here. We're going to have a force vector. And we're going to have the displacement, which is how much it moves. We're going to set these up very similar to the bearing problems where we have our magnitude, cosine angle, magnitude, sine angle for our x and our y. So our force, we're going to set up our vector. We have a magnitude here of 90. This is our magnitude. That's how much work he's doing. So we have our magnitude of 90, and it's moving using this angle because his force is coming down this way. So it's using this angle to mess with it. So we're going to have 90 cosine of 63. and 90 sine of 63. Our displacement is dealing with this 8 feet this way. What is the angle on our displacement here? 0. It's going straight east, like from our standard position. So standard position here is 0. So our displacement vector still uses its magnitude. What's its magnitude here? 8. It's going 8 feet that way. That's the magnitude, is the amount of displacement we have. So we're going to do 8 cosine of 0 and 8 sine of 0. What is cosine of 0? 1. What is sine of 0? 0. So we could rewrite this as 8 comma 0. This is the same thing. So what we're looking for now, we're looking for his total work. That's using that new formula we had on there, was work is the dot product of force and displacement. So we're going to do the dot product of these two vectors. So we're going to take and do our x's. So our 90 cosine of 63 times the x from our other vector, 8, plus the y's, 90 sine of 63, 0. This is why I simplified this one down a bit, because I didn't want to have to rewrite these out again if I didn't have to, because they're long. What's going to happen to this term over here? It's going to be 0, because anything times 0 is 0, so we don't got to worry about it. So all we need to do is to type into our calculator 90 cosine of 63 times 8. Which we can do that. We can even go 8 times 90 cosine of 63. Boop, boop. I just type it in like this. It's okay to switch the order. So we should get, is that what you guys got? Not what I have in my notebook, but I don't know why it's not matching. Oh, because I did my math wrong on the other piece. There we go. Okay. Yeah, I typed everything in right. Cool. So that would be our answer. 326.9. And we take our units here. So I have 1 unit up here that's feet, 1 unit that's pounds. So we put them both. Foot-pounds, because that's a totally natural, feels not at all weird thing to say. Physics makes choices. I'm not always going to say I agree with the choice of physics, but they make choices, and so we're stuck with them. Questions on this? The grossest part is writing out the vectors. The grossest part is figuring out your vectors. If you figure out your vectors, the dot product itself is mostly in the calculator. So we're going to do our other one, and that's our last one for the chapter. We got Kevin. Kevin's pulling his brother in a cart or a wagon with a force of 40 pounds. Must be a very little brother. The rope pulling the cart forms a 27-degree angle with the ground, and we're finding his amount of work if he pulls the cart 30 feet. So, naturally, I'm starting with a picture. So he's pulling a cart. Oh, we should probably give the cart some wheels. So he's got a cart. I am such a good artiste. The cart is forming an angle of 27 degrees. And we are pulling the cart 30 feet. That's his goal. He has a very long neck. That is a giraffe human. But that's okay. I will never judge your art, guys. Ever, ever. Because y'all know mine is a choice. My children know never to come to me if they need something drawn. My husband has a fine art degree. All right, so we're going to write our two vectors. We're going to have the one for the force that he's putting on the wagon.
You got the brother.
Oh, you're right. Let's see, let's give him a little brother. His little brother's bright pink. It's a very little brother. And he has one very long arm. That's okay. And then we're pulling our brother 30 feet. He also has no legs. All right. That's why he's in the wagon. Sorry, welcome to my brain. All right. So we're going to do our force and our displacement. We're moving on away from my brain on this random weird Thursday. Displacement. There we go. There's letters in there. We're going to assume they're the right ones. So, what is the vector for his force? The amount of work that he's putting into this wagon? 40. Cosine of 27. And then we're going to have our 40 sine of 27. Woohoo! So then let's do our vector for our displacement. What are we going to have here? 30 cosine of 0. And 30 sine of 0. I heard it. It was whispered, but I heard it. Which, again, we can rewrite that because we know cosine of 0 is 1. And we know sine of 0 is 0. So this is the same thing as the vector 30, 0. Because we can simplify our cosine of 0 and our sine of 0. Just so that we don't have to write as much when we're doing our dot product. So our work we get from the dot product. 40 cosine of 27 times 30. And 40 sine of 27 times 0. Okay, this one at least matches what I had down there. So we already know that this whole piece is going to be 0 because it's times 0, and so I don't even have to worry about this. So this guy's 0. So what do we get when we type the other piece in? Yeah, 1069 point, it doesn't say right around, so I'll just go 208. And we grab our units. I see feet, I see pounds, so it's foot pounds. Again, choices. Physicists are weird. It's like science and math got together and had a weird crazy. Yes, dear. I will absolutely take pound foots. That feels worse to say, but I don't particularly care. We're not doing physics-y things. As long as both units are there, I am 100% happy because you've done the hard math. All right, so last homework. This says unit test April 15th, which is Monday. Monday's awful. Let's do Tuesday. Because Monday's bad. So we're going to move it. We're going to move it back to Tuesday. So I will have the review for you guys tomorrow. Mostly because I want to go through it and try and find any typos myself first. So we hopefully don't have the, okay, question 2, change this, question 4, change that we've gotten on the last couple. So I'll have the review for you guys tomorrow. But so you guys can finish up homework 8-4, get any of them in that we need to, all that jazz. But that leaves us with then just the one test and then one more chapter and then finals. We're getting there, y'all. We're getting there.